Hello, everyone. So I think we are live. Thank you very much for joining us. We're a few minutes past the hour, but we're just going to give everyone a few more minutes to join. So whilst we wait, why don't if you go ahead and introduce yourself in the chat and let us know where you're joining from, and then we will get started in just a few moments when we've filled up. Expecting a few more. Good to see some familiar faces, or at least some familiar names joining, and some new names. Okay, I think, shall we get started? Let's give it another 30 seconds and then we should get started. There's still a few people joining. Okay, let's get started. Numbers have built up nicely, so let's kick this off. So firstly, for those of you that don't know me, my name is Charlie Cox. I recently joined OceanWise. I'm the microplastic solutions manager here at OceanWise. For those of you that are new to OceanWise in general, welcome. OceanWise is a ocean conservation charity. We're focused on empowering communities and individuals to take action to protect and restore the world's oceans. Now, before I go any further, I'd like to just start by acknowledging that I'm joining today's session from the city of Vancouver, which is located on the unceded territories of the Musqueam, Squamish, and Tsleil-Waututh nations. I'd like to also acknowledge that the indigenous people of these nations are really the original stewards of the ocean that surround this place. So we thank you for your stewardship and acknowledge your wisdom in teaching that conservation and stewardship is not a responsibility, but a privilege. So I'm grateful for the opportunity to be here and to continue that work. So with that, I will introduce today's webinar, which we have organized as part of our Plastics Free July campaign to encourage us all to reduce our plastic footprint. I'm joined, I'm pleased to say, by two of my brilliantly knowledgeable and passionate colleagues. That's Dante Ravenhurst and Dr. Shreyas Patankar. Dante is a program coordinator in our Shoreline Cleanup program. She is super passionate about data engagement and is responsible for implementing the cleanup program's data strategy. And Shreyas is a research scientist within the plastics lab and an expert in the field of environmental microplastics. His work has been central to OceanWise's efforts to stop the leak of microplastics into the ocean over the past several years. Today, we're going to be talking about the power of OceanWise's plastics data as a resource for driving impact on ocean conservation. So Dante and Shreyas are going to be talking about how OceanWise collects plastic pollution data, both downstream on the shorelines and upstream in the laundry and in effluent from wastewater treatment plants, for example, and how we then use the data to influence decisions, change behaviors, and pursue our vision of healthy, thriving oceans. So the plan for today is that Dante will kick us off. She's going to be talking about shoreline cleanup data, and she'll be followed by Shreyas, who will be discussing microplastics data, and then we will leave time at the end for a quick Q&A. So I've seen that some questions have already come in. Keep sending them in. We will try and get through as many of them as we can at the end. So with that, I will hand over to Dante.
Thank you so much, Charlie. My name is Dante, and I am speaking to you all today from Toronto, which is the traditional territory of a number of nations, including the Anishinaabe, the Chippewa, the Haudenosaunee, the Wendat, and the Mississaugas of the Credit. I am a coordinator with Ocean-wide Shoreline Cleanup, and I'm so very, very excited to be here today to talk about our incredible litter data. For my segment, I'm going to start off by introducing you all to our program. Then I'm going to discuss how data collection fits within our program, what types of data we collect, what our cumulative data set looks like, the impacts of this data, and I'm going to finally end on actions you can take to join our movement. So let's get started. So we really make up the downstream aspect of OceanWise's plastics data. So what do I mean by that? The shoreline represents this intermediary space between plastic sources and the ocean. In other words, litter data from the shoreline indicates both what ends up in the ocean as well as what's being produced and used on land. And this is such an important indicator of plastic pollution. And I think before I get into the nitty-gritty of our data, I think it's really important to zoom back and get a sense of what our program is all about. So Ocean-Wise Shoreline Cleanup was previously known as the Great Canadian Shoreline Cleanup. It's one of Canada's largest direct action conservation programs. Our mission is to inspire individuals to take action for their shorelines by keeping them clean of litter and plastic pollution. Since our very humble beginnings in 1994 with a single cleanup, we blasted off across the country. And volunteers with our program have collected over 2.2 million kilograms of litter, which I think is a pretty spectacular accomplishment. So what does running a cleanup look like with our program? So you or a group of your friends or your community group or your organization would register for a cleanup on our website, choose from one of our thousands of sites across the country. Then on the day of, you'd get your gardening gloves and your bucket and head to the shoreline to pick up litter. Now, what really sets us apart from other litter programs is our data. In addition to gloves and garbage pickers and a bucket, you would have an integral piece of equipment, a data card, which would either be accessible by a link on your mobile device that would be sent to you before the cleanup or through a hard copy that you print off from the website. And then you would submit the data following the cleanup. So what does our data card look like? It looks like this. So let's say you're walking along a site during one of our cleanups, collecting trash. You pull out your data card, which is this, and as you're collecting items and placing them in your bucket, you tally the items that you find according to the litter categories outlined in the right-hand side here. So for instance, let's say you grab a handful of trash on the beach and there's like 8 cigarette butts, 2 plastic cups, a plastic bottle, and maybe a balloon. You would tally each of those items into the respective categories outlined on the data card here. And then after the cleanup, you'd flip the data card to the other side and fill out these cumulative statistics. So the total kilograms of weight, the number of kilometers of distance that you cleaned, number of garbage bags, the number of volunteers that helped you on your cleanup. And so at the end of your cleanup, your data card is full of all the trash you and your team collected. And after your cleanup, you'd submit your data so that your individual piece of data from this cleanup would join forces with our national litter database. It's really important to understand that our data is completely citizen science driven, which I think is absolutely incredible. This means that everyday people like you and I are running cleanups through a program and then collecting litter data to contribute to this national litter database. The individual impact of these data cards might not seem like much, but when you think of hundreds of thousands of participants over time across a large geographical space like Canada, it creates an incredibly meaningful data set that can and has enacted equally meaningful change in the plastic reduction space. So I like to think that our data acts as a voice for the ocean. It tells us what's polluting our shorelines and waterways. So what has the ocean told us so far? What does our cumulative data set look like to date? So pictured here are the sites that have been cleaned in the last 5 years through our program. Over 3,000 sites. We have recently expanded our geographical reach to California and Texas, which is very exciting for us at Shoreline Cleanup. So we'll hopefully continue to have site representation across the entire continent of North America. Since 1994, our program has facilitated over 32,000 shoreline cleanups, the collection of 2.2 million kilograms of trash, and what I find the most inspiring, we've motivated almost 1 million volunteers to date to participate in our program. What I like to think about is that if you read between the lines of these statistics, this doesn't account for the number of individuals that have been inspired to implement behavioral change in relation to plastic reduction in their day-to-day lives through the lens of our program and data collection. So now we have an understanding of how our data is collected and what the cumulative results of this data look like. Now we have to ask ourselves, why does this data matter and what is its impact? So it's really challenging to enact change in relation to marine pollution without understanding key sources of this pollution. And our data provides a knowledge base for what these key sources of pollution are. So every year we publish the top 12 items that are collected in shoreline cleanups across the country in our annual report. And we call this top 12 list our dirty dozen. So you can imagine this dirty dozen list might change from year to year. Some of the items might vary, but we often have frequent flyers. These are what we call items that show up in our dirty dozen list consistently year after year after year. A lot of those items you can imagine are plastic. So things like plastic pieces, styrofoam pieces, plastic bags, plastic bottles, plastic cups. In this way, our data is able to tell us what these heavy hitter plastic pollutants are in the water. And as another example of the other types of information that our data can tell us, at the end of 2020, we added PPE, so personal protective equipment like masks and gloves, as a litter category on our data card. And this allowed us to track the environmental impact of the pandemic for the first time. At the end of 2021, as you can see in this list here, number 12 was PPE items. This illustrates how key litter items have evolved since the onset of the pandemic. And this is something that our data is able to tell us. Understanding key players of marine pollution can inspire behavioral change on a citizen level, but also it can empower legislators, researchers, conservationists, and industry leaders to enact meaningful changes within their respective communities as well. And ultimately, the outcome that we want and that we hope for, and I believe that we can achieve, is we want this to result in a reduction of plastic in the ocean. And we want to be able to assess, are our actions actually working, and are those results showing up on the shoreline? So what can our data actually do? What impact has our shoreline cleanup litter data already had? And there are three main areas of impact, which are based off of the groups that can be actually empowered by the knowledge that this data provides them. So this includes legislators, businesses through our Shoreline Champions program, and municipalities through our Clean Shoreline Communities program. So these are just some of the most recent ways our litter data has already contributed to policy change in relation to plastic reduction across the country. So in 2017, the city of White Rock and the Surrey Naturalists shared our data to restrict the use of expanded polystyrene foam on waterways. Flash forward to 2018, the city of Vancouver utilized our data to produce their single-use item reduction strategy. In 2020, our data was used by a report published by the government of British Columbia with the aim of making policy changes related to encapsulated foam floats. Policy is a really great starting point in enacting systemic behavioral changes related to plastic reduction. We're illustrating that we have the ability to inform that first step with our data and hopefully keep goals in line by tracking impact over time. Now, this is truly a piece of legislation that we are incredibly proud of informing. This is Canada's single-use plastics ban. So way back in 2019, Prime Minister Justin Trudeau's office issued their announcement stating Canada's commitment to eliminate single-use plastics. Shoreline Cleanup's data was cited in the press release as a reliable source of information on the topic back then. We have been part of this from the ground up. In 2020, our data was then used as a main source of information for quantifying shoreline pollution in Canada's science assessment of plastic pollution. The importance of this document is that it was integral to informing the actual legislation of the plastics ban that took effect earlier this year. And this ban prohibits the import and manufacturing of 6 plastic items: checkout bags, cutlery, takeout-ware with plastics that are challenging to recycle, plastic, aluminum, can ring carriers, stir sticks, and straws. So what's interesting about this is not only did we inform the initial legislation that produced this ban, we track 4 of the 6 items that are included in this ban. So we will actually be able to assess the impact of this legislation over time. So in addition to legislation, our data has an impact in relation to businesses through our Shoreline Champions program. So in this program, businesses that sign up for becoming a Shoreline Champion receive support from one of our team liaisons, so me or one of my wonderful colleagues, and we help plan and coordinate a cleanup event. We help source supplies for the event, we support communications and engagement, and following the event, we provide an impact report to the Shoreline Champion, outlining all of the data that was collected during cleanup, and then we help them share that impact with the world. In this way, we're inspiring behavioral change through the lens of our data. And using this data to shed light on the impact of plastic pollution on shorelines, each participant within the Shoreline Champion can be motivated to reduce unnecessary plastic waste in their lives and in their workplace. We are employing our data to celebrate impact, as well as to bring awareness to the effect of plastic pollution in our communities. Our data is also a really effective tool for municipalities through our Clean Shoreline Communities designation. So through this, we build partnerships with municipalities. We award a designation to municipalities that agree to work with OceanWise to address issues of litter and plastic pollution in their communities. We provide a framework for self-assessment so that municipalities can actually create baselines of the work that they have already done, if any, to target plastic reduction within their community. And then we also provide a framework for goal setting so that they can accomplish their aims. And one of the components of this program's offering to municipalities is a data package. In this way, municipalities then are able to make data-informed decisions on not only municipal policies, but also community-wide programming and practices, such as waste management, for instance. So whether the municipality is already actively addressing plastic pollution litter or are seeking solutions to this really important issue, the Clean Shoreline Community designation has a program option for all of levels to help increase and measure impact. It's clear from what I just described that our data has made an impact and will continue to do so. And looking to the future, our data also has the ability to be a metric of progress for plastic reduction efforts. We're at a time where action not only matters, but tangible impact is very, very important. Looking forward, our data can inform legislation, assess the effectiveness of current plastic reduction legislation and policy, as well as empower municipalities, businesses, and citizen scientists to manage their plastic footprint by illustrating the impact of the actions that they're making. The shoreline doesn't lie. We can use our data to keep us in line with our plastic reduction related goals and ensure that the actions that we are inspiring are also resulting in tangible change. What I think is truly incredible about our data is that it demonstrates the cumulative effort and power of individuals, of over 20 years of tens of thousands of cleanups of effort. This data has incredible potential. It can enable legislation, inspire businesses, and empower municipalities to enact change in relation to plastic pollution. But the way that I like to think about it is that it's not just the data that's doing that, it's the almost 1 million volunteers through our program that have made that possible. And on that note, there are many ways that you can join our movement. You can lead or join a cleanup of your own through shorelinecleanup.ca. We encourage you to collect and submit your data. If you are a municipality member, you can consider a Clean Shoreline Community designation for your municipality. If you're a business, you can consider becoming a Shoreline Champion. And if you're a researcher or a legislator, consider using our data. It's open source to inform your work. Thank you so much for taking the time to listen to me exude my passion for our data. With us capturing the essence of the downstream component of OceanWise Plastics data, I'm now going to pass the mic over to my brilliant and inspiring colleague, Dr. Suresh Patankar, who will discuss OceanWise's upstream component and its relation with the OceanWise Plastics Lab.
Hello, everybody. Thank you, Dante. That was really interesting, and I'm looking forward to following up and giving the other flip half of the story of plastics at Oceanwise. My name is Shreyas. I am a research scientist at the Oceanwise Plastics Lab, and I am calling in today to this webinar from the traditional and unceded territories of the Musqueam, Squamish, and Tsleil-Waututh nations, and I live in Vancouver, BC, in Canada. I, like Dante, I'm really heartened to see so many of you take the time out of your day on a Thursday afternoon. I know it's not the best weather we have here in BC, but it's really great to see so many of you caring about this issue enough to spend time with us. So what I'm going to talk about is, like I said, share some insights from what we've learned about plastic pollution in the ocean, or what we as the scientific community knows about plastic pollution in the ocean. And secondly, to tell you a little bit about work we have done on upstream solutions to combat the challenge of plastic pollution in the ocean. And then finally, I'm going to copy Dante's enthusiasm and tell you all about why we should all be data nerds, and really emphasize that data is important, even if it is not pristine, especially if it's dirty and imperfect and gory. That's when it can really serve its best purpose. So that's part of why we really wanted to talk to you about this topic and share our enthusiasm with you. So to get a little bit into the part of the work that I do on a day-to-day basis is with microplastics, and I'm fairly confident most people in the audience know about this term, but just so we are all on the same page, microplastics as a technical definition that is agreed by scientists to be less than 5 millimeters, that are synthetic polymer pieces or particles that are less than 5 millimeters in size. Why do we have this cutoff? It seems a little arbitrary. It is arbitrary in a sense, but it's put there because that's where it's thought to be bioaccessible. So particles under that threshold are more likely to be accessible to marine organisms through either ingestion or entanglement or what have you. Another part of the story that many of you might be familiar with is microplastics can either be primary or secondary. So they can either be made to be, plastics can either be made to be microscopic sized, or they can be made to be human sized and then degrade down to microplastics through a process known as weathering. And this is a bit of a story of what the environment, specifically oceans, do to plastic materials when they are in that environment. So a plastic bottle or any other item, when exposed to the ocean, includes an exposure to ultraviolet light, to salinity, to acidity, to different living organisms. So it, through a combination of physical, chemical, and biological stresses, breaks down into microplastics and nanoplastic, and then eventually down into individual molecular structures. And this is the reason we talk about them separately sometimes, is because of the effects that they have on the health of our oceans. So getting back to my to where I started off with, is what is the ocean telling us? And it turns out the story is complicated. So the scientific community has a couple decades or so of history at this point, where scientists go out and find microplastics in the ocean, and we are all concerned about it. What has been challenging up till now is to get precise numbers on any of these measurements. So because this is such a new field of research, and because it is so complicated to do these measurements properly, the error bars on these measurements can be quite large. So the best numbers we have are between 1 and 1,000 microplastic particles per cubic meter of water measured in different parts of the world. And there are variations based on location, obviously, as one might expect, and also based on depth. Something that has become a more and more accepted conclusion in recent years is if you try to say what are these microplastics or say more about the microplastics, it's becoming more clear that polyester microfibers, so microfibers as in microplastics that are fibrous in nature, are the most common, and specifically polyester microfibers are the most common. And this is something that is still being investigated, and these are a difficult phenomena to study, but that's what's been found. And even more new and newly studied field of research is looking at microplastics in sediments. So these are scientists going down into deep ocean sediments and trying to analyze microplastics. And now there is quite conclusive evidence that there are abundant microplastics in ocean sediments. And the numbers and concentrations vary, but people are finding up to 1,000 microplastics per kilogram of ocean sediment. This is a new field of research, but even still, there is quite a bit of evidence that microplastics in sediment account for a very large fraction of all microplastics that end up in the ocean. So there are some estimates that say around 99% of all microplastics in the ocean are actually in the deep ocean sediment. And once again, there is some evidence that polyester microfibers make up a bulk of microplastics in these sediment samples as well. A piece of this kind of research that connects with me personally was from our lab a couple years ago, where we had a team of researchers go on a research vessel on an expedition in the Arctic. And they collected water samples in the Arctic Ocean on the surface and at several depths and analyzed them for microplastics. Now, just for context, remember this, we're talking about the Arctic Ocean, which is there are not that many people around, and it has extreme climate and temperatures, and we would normally think of it as pristine. But this study that we conducted found microplastics particles in every single sample that we studied, and the concentrations ranged between 50 to 100 approximately microplastics per cubic meter of water sampled. The dominant contribution here was from polyester fibers, and we did some follow-up analysis on these samples, and we think there's some suggestive evidence that these polyester microfibers are similar to what one would find in consumer textiles that are used by people in the US and Canada and Europe. And there's some evidence that that's how these microfibers are making their way to the Arctic. It is very difficult to study microfibers in water, in ocean water. And there's some tantalizing bits of evidence already that even though there's been a lot of data on polyester microfibers, there might be some contribution from other human origin microfibers, most notably cellulose. And that's where some of this research gets really tricky, because is cellulose a plastic? In the standard definition, one would say no, but that answer I would suggest needs to come from what biological effects or ocean health effects we are interested in. But I won't get into that too much detail on that unless people are interested. So now that we have a clear understanding of what, at least the first level answer of what the ocean is telling us, at OceanWise, at the Plastics Lab, we did a little bit of research on figuring out upstream solutions to how we can address this problem. and that has to do with starting with the using a starting point as home laundry and the microfibers that are shared in home laundry, and understanding how we can use that as a target point for reducing microplastics. So this was our quite extensive study on doing a very controlled set of experiments to understand the relative rates of microfiber shedding from different textile materials. And what we found was for a given load of materials, so we tested several chemistries and several material constructions, we find a shedding rate of between 100 to 1,000 approximately milligrams per kilogram of fabric. But the striking piece here was the large variation and the large error bars, as you can see in the chart on the left here. We found that the shedding rate depends strongly on material construction, yarn type, mechanical treatment, and chemical treatment. Now, based on these numbers, we thought it would be nice to do a macro scale picture of what that looks like. So we know something about consumer habits of people in the US and Canada, and we estimated that about 500 million microfibers are released per household per year in a common household in the US or Canada. This adds up to 84 quadrillion microfibers being released into the urban waste system every year. Now, it turns out, and we have some research that agrees with this, that the wastewater treatment systems in most of US and Canada are actually quite good at capturing microfibers. But just because the volume of microfibers coming in is so large, even the little bit that gets away is still a big number, and that is about, in our estimation, 3.5 quadrillion microfibers. And to put that in context, that's about the equivalent weight of 10 blue whales. As a part of the study, we thought about using we thought about analyzing one home mitigation method. So this is several manufacturers now make laundry lint filters, and we found that they're actually quite effective at capturing microfibers in different materials. But our caution is that this is not a magic bullet, and especially one has to be careful about what one does with the microfibers that are captured in these lint filters. So the worst thing, obviously, that you can do is wash them down the drain, which would negate the entire purpose. But there aren't really great answers to address that problem. So where I want to leave you is to draw us back to the importance of data and the importance of scientists and decision makers being clear with each other and transparent about what are things that we really know and what are things that we are uncertain about. And this is where I think it is important for everyone to really get their hands dirty and know how dirty data can be. And I wanted to highlight our collaboration with two really exciting projects. So these have to do with regulators in the state of California having ambitions to reliably quantify microplastics in the next couple of years. And one of the projects that we've been working closely with is OpenSpeccy, that relies on community contributions and using big data technology to help us all improve our microplastic analysis capabilities. And the second project I wanted to highlight was it is called Tomex, and this is using the same concept of community contributed big data, but this time applying it to get a better understanding of toxicity and getting accurate information on what biological effects are quantified for microplastics on different species of living organisms. So that's more or less where I would leave you. I I'll share a little bit about the plastics lab and what we do. Our work is focused around three key directions: the microfiber partnership, work on urban plastics and urban pathways for plastics, and trying to study biological effects. And I'm very happy to speak with any of you either in the Q&A or separately, and you can find my contact information here. And I will hand it back to Charlie.
Okay, thank you, Shreyas. And I will let you take a bit of a breather. There's some questions that are coming your way in just a moment, but I will start with some questions for Dante about the first part of our presentation today. And there's some good ones here. I'm going to start with two for you, Dante, if that's okay. But I think the second one is maybe one that you can share because I think there's some crossover. So let's start with, thank you, Kyle. This is, how accurate do you expect the data cards to be? So I guess this is a question about citizen science in general. Are you hoping from those data cards to get a general idea of what is collected, or for precise information? What are you aiming for, and what are you getting? And then, okay, go ahead and I'll come back to you with the next one afterwards.
Okay, awesome. Yeah, thanks so much, Kyle, for that question. As Shreyas mentioned, data can be valuable even if it's not pristine. So our data cards themselves are, accurate, but of course there are flaws in citizen science data collection. But I think the key with citizen science is that it's citizen science collected data is collected at such a high volume that it still does give us a relatively accurate depiction of plastic pollution. So precise, no, but still highly valuable and paints an important general picture of the key players of plastic pollution, absolutely.
Great, thank you. And then this next
one, I know this was a question for Dante, but if I can jump in there as well, I'll add that people like the scientific researchers who do data collection for a living often make mistakes and often have large errors in their data collection. So it is completely understandable that in citizen science, when people are doing this of their own free will, are going to have different levels of accuracy in their data collection. But it really, when it's all aggregated together, it still really is valuable. So I really have a great admiration for the massive database of citizen science data from the Shoreline Cleanup. Sorry, Charlie.
No, go ahead. I've got another one that I think maybe you can both weigh in on, and this is from Rhiannon at City of Victoria. So how can our plastics data support municipalities to reduce waste? So I think we can talk both about the Shoreline Cleanup work and then also how the lab's working with municipalities as well.
So for Shoreline Cleanup, that's a great question. So for Shoreline Cleanup, our data includes compositional litter data as well as geographical data that's associated with sites where people have done cleanup. So if you're a municipality and you have an informed understanding of what the key players of waste are, and that's coupled with geographical data, what the municipality has that complements that beautifully is context. So they might have if let's say a key player of plastic pollution is plastic bottles, there might be a reason that the municipality has through the context and background that they possess that they might be able to be like, oh, okay, this is why. So using our data coupled with the background and context that a municipality has, you can implement targeted waste management policy.
And I'll add a little bit onto that, which is, so I'll first say that the piece that Dante mentioned is the most important piece. Municipalities have like the one tool in their toolbox is land use and permitting and waste management. That is where having some data or some clarity on what your region is responsible for is really, really valuable. And that's where municipalities can direct action to have targeted action to stop the flow of microplastics. So a piece of work that we help municipalities with, and I'll again emphasize that this is less important than the piece that Dante mentioned, but this has to do with wastewater treatment and waste management in general. And we are trying to think through different technological innovations that can help. So it's a downstream solution in a sense, but maybe mitigate the flow of microplastics to the ocean. But obviously, the most important thing we can do is stop the plastics coming in the first place.
Thanks, Shreyas. I'm actually going to come back to you with another one, Shreyas, if that's okay. Let me just find it now. It's from Stephen. Thanks, Stephen. And it is, so are polyester microfibers the most abundant in terms of number of particles or by mass or both?
That is a great question. And let me just preface it by saying this is it is very hard to do these measurements, like I said, and every scientist uses their own methods and gets a slightly different answer. But I think we can agree that it's polyester microfibers are abundant. And the specific answer to your question is almost always people talk about numbers and not mass. And this has to do with two reasons. One is there's some suggestion from toxicity research that it's the abundance, the number, that is a better correlator with biological effects than mass. And the second is a lot of the techniques that the most common techniques that we use are better at capturing numbers than at getting the mass. It's not a blanket statement, but true for the most part.
Great, thank you. So there's another one here that I might be able to have a stab at, and that Shreyas also you might be able to weigh in on, and that's about creating experiments or sensors that would be able to determine the level of plastic contaminants in ocean or lake water, which could help drive data-driven citizen science initiatives. And what I will say about that is, I guess it's difficult to create something that's low cost in that scenario, but we are working on something quite exciting at the moment in partnership with the Canadian Sail GP team, which is a competitive sailing team that's competing at events all over the world. We are their impact partner, and they are essentially going to be conducting some citizen science water sampling experiments on our behalf in the venues that they're competing at. So they're doing a tow net sampling experiment. They will collect a sample of seawater from, there's one in Plymouth, UK, then Dubai and Singapore and all of these places. And we will then receive the samples and be able to do our analysis of them and have a comparative data set of the water across all of those different or in the ocean in all of those locations, which is super exciting. And with all of the caveats of citizen science that Dante and Shreyas have been talking about earlier, it still is an amazing resource for allowing us to do experiments that we wouldn't otherwise be able to do. So we're always looking for those sorts of initiatives to be able to add our expertise, but also leverage the power of volunteers and citizen scientists. Shreyas, I don't know if you want to add on to that at all, or shall we do another one?
I'll do a quick add-on, which is, like I said, having data of any quality is really, really useful. So anything from people just going out by themselves on a walk or in a little vessel and collecting a sample, all the way up to some top of the line labs that have autonomous drones that do microplastic samplings. Both of those and everything in between is valuable. So if you, wherever you fall on that spectrum and you want, if you'd like to talk more about data and how that can be useful, please get in touch and we would be happy to chat about that. And we have worked with people on different ends of that spectrum, as Charlie mentioned.
Great. And Shreya, sorry to bombard you, but I found another one that I think has your name written all over it. It's about, so this is Kyle. It's about the sediments that you were talking about, microplastics in sediments. Is there a depth that microplastics could be buried under sediments where they're no longer considered problematic?
I'm so glad you asked me about this because I didn't have time to talk about it during my presentation, but I can spend some time talking about this now. So I'll answer the latter half of your question first, which is, can they be buried deep enough that we, quote unquote, don't have to worry about them anymore? And I would say nobody really knows the answer to that, and we have to be super, super careful when making decisions based on that kind of analysis. We don't know what effects microplastics have wherever they are. So even in sediments, there are effects on sediment feeders that can affect ocean health. Now, the first part of your question, are there microplastics at different depths? So this was the study I briefly hinted at, where scientists have drilled holes into sediments and quantified abundance of microplastics versus depth, and hence you can correlate that with how many decades they have been under in the sediment. And I've seen this beautiful published graph which shows an exponential growth in microplastic abundance. If you go past sediment that has accumulated pre-1950, you don't see anything, and then you start seeing microplastics in the 50s, 60s, 70s. And then after the 80s, there's an exponential growth in the abundance. So to me, that's really, well, as a scientist, it's fascinating. As a conservation person, it's a little chilling to see those numbers.
Thanks, Tress. And I feel like, Kyle, I've seen a follow-up question as well. So maybe we can continue this conversation. I've just posted in the chat some ways of getting hold of us. They're also on that last slide there as well. So yeah, I would really encourage all of you to reach out if we didn't get to your question, or if we didn't provide a satisfactory answer to your question. You can let us know, get in touch, email us if it's a plastics lab related question. Get in touch with Shreyas or myself. If it's a Shoreline Cleanup question, then get in touch with Dante, and all the social media links are there for you. I think that's just about all the questions that we have time for today. And so, yeah, I would just, emphasize, please get in touch if there's anything we haven't covered. And also, I guess just like to conclude the session today. I will, reiterate that our mission here at OceanWise is to empower communities, empower individuals, as we said earlier, to get out there and start protecting and working on restoring the ocean. So, as we've hopefully shown, as Dante and Shreyas, I think, have shown, it's really our data that is the key resource that we have to be able to do that. So whether it's the citizen science data that we've talked about in shoreline cleanups that can influence policy making for municipalities, or if it's Shreyas's microplastics data that can help us come up with interventions upstream in the apparel industry. It's just such a key part of what we're doing, and hopefully we've been able to show that. thanks everyone for joining us today. I hope it's been interesting, and I really would encourage you all to keep engaging with OceanWise's plastics data. So stay in touch on social media and through the links that we've posted there. There's also an event coming up that I would flag for your attention. I know the Shoreline Cleanup team will be promoting this a lot through our various channels, but there is International Coastal Cleanup Day coming up on September the 17th, and we're hosting cleanups across the country. There's one in Vancouver here, in Toronto, and I believe Halifax, but I might be wrong. Anyway, that stuff will all be being talked about online, so stay tuned for that, and hopefully we'll see you down there on the shoreline. Thanks again, everyone, for joining. Thank you, Dante and Shreyas, for those presentations, and thank you all.